Hello students, in this video we will discuss some numericals of Newton's laws of motion. We have completed the theory of Newton's laws of motion. Now we will do some numericals. A question is written, a ball of mass 10 gram initially moving with a velocity of 50 meter per second on applying a constant force on ball for 2.0 second, it equates a velocity of 70 meter per second. We have to find what is change in momentum and what is a force. Mass of ball m equal to 10 gram. We have to convert it into kg. 10 by 1000 kg means 0.01 kg. Initial velocity u is equal to 50 meter per second. Final velocity v equal to 70 meter per second. Time is given 2 seconds. First, we have to find change in momentum. Change in momentum. Means final momentum minus initial momentum. Minus initial momentum. Final momentum mass into final velocity, initial momentum mass into initial velocity. Momentum P is equal to mass into velocity. Mass 0.01, final velocity 70 minus mass 0.01, initial velocity 50. If we take 0.01 common, then 70 minus 50 or 0.01 into 20. So 0.2 change in velocity, change in momentum. Change in momentum 0.2 kg meter per second. Then we have to calculate force. Second bit B, we have to calculate force. Force is equal to rate of change in momentum. Rate of change in momentum. That equal to del P by del T. Change in momentum. This is the change in momentum. Del P. 0.2. Time is 2 seconds. 0.1 Newton. Force equal to 0.1 Newton. Understand? Next, we will do another questions. Now, second question. A hammer of mass 500 gram moving at 50 meter per second strikes a nail. The nail stops the hammer in a very short time of 0.01 second. What is the force of nail on the hammer? Mass of a hammer m is equal to 500 gram. We have to convert it into SI unit. 500 by 1000 kg. 0000 cancel. 5 by 10 0.5 kg. What is the initial velocity of a hammer? u equal to 50 meter per second. Finally, the hammer is stopped by nail, means final velocity v equal to 0 meter per second. What is the time interval of change in velocity? Time interval is 0.01 second. What we have to calculate? Force. Force is equal to rate of change in momentum. Rate of change in momentum. That is equal to del P by del T, or final momentum minus initial momentum by time. M into V minus M into U by T. Mass is 0.5. Final velocity is 0. Minus mass is 0.5. Initial velocity is 50. By time 0.01. 0.5 into 0, 0, minus 0.5 into 50. 0.5 into 50 you multiply. 5 into 50, 250. After 1 plus you will put the decimal. So it will 25.0 by 0.01 minus 25 into 100 by 1. So minus 2500 Newton. Why the negative sign is here? The negative sign is the opposing force. It is the opposing force applied on hammer by the nail. So it becomes negative. Now it is over. Now we will discuss third question. Now I have written the third question. A 1.2 kg basketball traveling at 7.5 meter per second hits the back of a 12 kg wagon and bounce off at 3.8 meter per second, sending the wagon off in the original direction of travel of the ball. How fast is the wagon going? Here, the momentum of the ball before collision is equal to the momentum of two objects after collision. But we have to apply here the law of conservation of momentum. Momentum of the ball before collision is equal to sum of momenta of two objects after collision. According to the law of conservation of momentum, we will apply this, that momentum of the ball before collision is equal to the momentum of two objects, that is wagon and ball after collision. Before collision, mass of ball m is equal to 1.2 kg. Here we will consider the original direction of the ball is positive. Let us consider original direction of a ball is positive. First velocity or first direction of the ball we will consider as positive. The ball is moving at 7.5 meter per second. Velocity V1 is equal to 7.5 meter per second. Now, after collision, velocity of ball V2 is equal to, the ball is bounce off, means its direction changes. Its direction is opposite to the original direction, that is negative. V2 equal to minus 3.8 meter per second. But the wagon travels in the direction of a ball. The velocity of wagon, we will take plus V. If we apply the momentum of ball before collision is equal to sum of momenta of two objects after collision. Momentum of ball before collision is equal to momentum of ball plus momentum of wagon. This is after collision. Before collision, mass 1.2, velocity is 7.5. After collision, mass of ball 1.2, velocity is minus 3.8 plus mass of wagon 12 kg and its velocity after collision is plus V. Now we multiply 12 5 is 60, 0 plus 6, 12 7 is 84 plus 6 90. After 2 plus decimal will be placed. 12 8 is 96, 6 plus 9. 12 into 3 36, 36 plus 9 45. After 2 plus decimal is placed. Plus 12V. 9 plus 4.56. When we shifted this one to this side, minus become plus is equal to 12V. I will write here 12V is equal to 13.56. V equal to 13.56 by 12. 12 on the 12, decimal 12 on the 12, 12 tija. 1.13 meter per second. The velocity of the wagon is 1.13 meter per second. Understand? Now we will discuss next question, fourth question. Now this is fourth question. A hockey ball of mass 200 gram traveling at 10 meter per second is struck by a hockey stick so as to return it along its original path with a velocity at 5 meter per second. We have to find the change in momentum occurred in hockey ball. Mass of ball m equal to 200 gram. 200 by 1000 kg means 0.2 kg. Initial velocity u equal to 10 meter per second. V equal to final velocity V equal to minus 5 meter per second, because the ball return along its original path. The ball is returned along its original path. Change in momentum. What is the momentum change? 0.2 into 10 minus 0.2 into minus 5. If we take 0.2 common, then 10 minus 5 or 0.2 10 plus 5. 0.2 into 15. 3.0 kg meter per second. This is the change in momentum. Understand? Next we will do another questions. The question is, a bullet of mass 100 gram is fired from a gun of mass 20 kg with a velocity of 100 meter per second. Calculate the velocity of recoil of gun. Now you see, before firing, bullet and gun both are at rest. Therefore, momentum of system before firing is 0, because both gun and bullet are rest. So the before firing the momentum is a 0. After firing, velocity of bullet V is equal to, or V1, 100 meter per second. Let recoil of gun, we will take V2. A recoil of gun, the velocity of recoil of gun, velocity of recoil of gun is V2. Therefore, momentum of the system after collision mass of bullet 100 gram by 1000, 100 by 1000 kg mass of bullet into velocity of bullet 100 meter per second plus mass of gun 20 kg into velocity v2. According to law of the conservation of momentum, according to law of conservation of momentum, momentum of system after collision is equal to momentum of system before collision. That means here double zero cancel, 0 को 0 cancel. 10 kg meter per second plus 20 v2 is equal to 0. Momentum of system before collision is 0. 20 v2 equal to minus 10. v2 equal to minus 10 by 20 means minus 0.5 meter per second. Why this velocity is by negative? Because the motion of gun is in the opposite direction of the bullet, so it becomes negative. Hence, velocity of recoil of gun is minus 0.5 meter per second. In this video, we have discussed 5 numericals, 5 questions, and several other numericals are there. We will discuss in next videos. If you like my video, you like it, share and subscribe it, by which I will encourage and more video I will be uploaded.